Hello, everyone. We have 17 people registered for today, so I'm just going to give it another minute and see if we have any stragglers that are joining us. There's still people popping on, so I just want to give them another minute before we get started. You'll notice that I'm looking to my left now and again. That's because I have all of your beautiful faces. For those of you I can see, I have your faces up on my screen here to the left, as well as I have the chat feature open as well. So feel free, if you have questions throughout, you can either come off of mute, turn your cameras on, and feel free to interrupt me at any time if you feel comfortable. If not, there's also the chat feature, so you can definitely feel free to write a message either to the group or just individually to myself in the chat feature and interrupt me there or ask any questions. I'm happy to do so. I am going to drop my email address into the chat so that if anyone has any questions later on and they want to connect with me offline, they can feel free to do so. All right, I think we've given those stragglers just about enough time. So for those of you that don't know me, I'm Kristen Mogg. I work with Spectrum Educational Supplies, and I have the pleasure of representing the LEGO Education brand. You guys signed up for today's webinar, so you already know that it is featuring the LEGO Education WeDo 2.0. We're going to give you an introduction to the product platform, as well as we're going to be doing an app walkthrough as well, and I'm just going to show you the features of that. I have scheduled an hour and a half for today's session, mostly just because I wanted to make sure that we had enough time to go through everything, and if there were any questions, then people could engage in the session and interrupt and ask questions as they wanted to, or if there's a specific feature that you'd like me to dive into a little bit more, we can do that. I'm actually only anticipating that the session will take about an hour and 15 minutes. But like I said, I just wanted to give us a little bit of extra time if needed. If anyone needs to leave early, feel free to do so. I understand that as well. And I appreciate you taking the time on spring break to join us. So without further ado, I am going to jump into this PowerPoint presentation that I have set up. Can everyone see my screen? Got some thumbs up, great. Excellent. I always ask if people can see my screen, and I think usually I'm actually better off asking if people can't see my screen. They can let me know that way. So that's always good. Working with tech is fun, right? So WeDo 2.0 is a primary robotics platform. It's LEGO's kind of level 1 of robotics in their continuum. So they have WeDo 2.0, they have the newly released Spike Prime, which I actually have done a previous session on, and we'll have more sessions on Spike Prime coming up. And then probably the most well-known is the LEGO Mindstorms EV3 platform, which is actually it's just been announced earlier this year that EV3 will be retiring. So we really won't have a lot of content for EV3. So WeDo 2.0 is kind of perfect for that grades, well, kindergarten it can be introduced in, but ideally in grades 1 to 3 is where it fits best. And it's a hands-on learning solution. And LEGO has this philosophy of hands-on, minds-on. And really what that means is if our hands are busy, then our minds are often busy and engaged as well. The product really lends itself to different decision-making and challenges, exploration, a little bit of design engineering as well as the students are learning. It's excellent for memory encoding and the retrieval process. So taking what they've learned from previous experiences and applying it to the specific models within the WeDo core set. or taking what they've learned from the WeDo course set and applying it to real life scenarios. So we're really exercising the brain here. They're going to be exercising control skills, pushing out those distractions. So that kind of falls into the hands-on, minds-on. You know, if we're engaged, then we're not allowing ourselves to be distracted by other things that are going on. And we really have the benefit of short-term and lifelong learning concepts by using this product. It's very, all of LEGO's products, because it's encouraged that they're working in groups, ideally in pairs or more realistically in groups of 4, they really get that collaboration and that social interaction by working together. And the LEGO pieces, outside of the mechanical electronic pieces, but all of the LEGO pieces can be sanitized and cleaned as well, which I know is a growing concern with the pandemic. The idea with LEGO 2.0 is that we're engaging all of our students. They're going to be working collaboratively and using kind of that natural curiosity, and they're going to be exploring different STEAM problems. Personally, I find the WeDo 2.0 platform is ideal for teaching a lot of the science curriculum. It ties into grade 2 and 3 science very, very well. It has that intuitive LEGO building brick system that a lot of students are familiar with, and I'm sure a lot of you on the call are familiar with as well. It's got a classroom-friendly software, so it's a block-based coding platform that's very easy to use. It's drag and drop, and it uses both text in terms of identifying the names of the different blocks, as well as just the icons, so visuals, to help the students recognize what each block means and what it's going to do. It does align with a lot of Canadian or Ontario-based curriculum, depending on what province you're joining us from. However, the curriculum that is provided within the LEGO set is based on next generation science standards or Common Core. However, I'm going to give you some examples today, hopefully, where you can see a direct correlation between the lesson plans and the activities that are made available in the software and how they're going to fit with your provincial curriculum. Ultimately, we're going to be improving computational thinking and bringing topics to life like science, math, and engineering. And like I said, I really see a very strong science connection with this platform. So we're making these models come to life, which makes it really engaging for students. They're going to see science concepts come to life in the classroom. There's that basic programming skills, critical thinking, and problem solving that's going to be addressed as well. And as I mentioned, that collaboration. And what I haven't mentioned yet is the presentation skills. So there's a lot of sharing that's going to go on or encouraged within this set, where they're going to be sharing with either another group or the entire class, or maybe through a video recording where they're going to share what they've learned, what they've created, and how they got there. They're going to be kind of investigating, modeling, and designing different solutions, and so they're going to be able to share that. What's nice about the set, and I'm going to be able to show you, there's some really easy getting started activities that you can have models up and running in about 15 minutes, which is really ideal for the classroom setting. That student engagement is obviously huge, and we're going to be looking at developing different skills as well. So now let's take a look at what comes in the set. So the Lego storage bin is actually a different size than we've seen previously. So it's actually a much shorter set than, let's say, EV3 or NXT or Simple Machines, depending on what sets you've had exposure to in the past. So it's a little bit of a shorter set. It's still the same width and length, and does hold those. We can only see you, not any slides if there are any. I just got someone in the chat. You guys can't see my slides. Let me turn my screen sharing off and see if we can get that fixed for you. I'll switch. New share. Paul says he can see all the slides just fine. Christine is saying that she can't see the slides. Okay, I've just I'll stop sharing. We'll reshare. Thanks for piping up, Christine. Is anyone else having trouble seeing? The chat up again. Good now? Okay, maybe I just needed to reshare. Thanks, Christine. Sorry, guys. So there's the set's a little bit smaller, like I was saying. However, there is a ton still in there. So there's 280 of the building elements. There's the smart hub, which I have, I'll try and show you. I have a model built already. So the smart hub is the controller of the robot. It has built-in Bluetooth as well. You can use it with batteries, or you can purchase a rechargeable battery and charger, which is a lot more classroom friendly. It does come with one medium WeDo motor as well. You can kind of see it on the back here for mine. Then there's also two sensors that are included in this set. So there is a motion sensor, which is similar to like the distance sensor. It's just rather than measuring different distance, and the accuracy isn't quite as good. So it's really, which is why we're identifying it as motion. And then there's also a tilt sensor, which is kind of an introduction to a gyro sensor. So it can tell when it's tilted in different directions. There's the sorting trays. There are stickers for organization and labeling, which makes it a lot easier for classroom management. So you got our sorting tray. I can't tip it too much, but we got a sorting tray here. I left my stickers off so I can actually show you. So it's got these different stickers that fit inside of the storage trays. And this is great for organization and for the students at such a young age. Then they know exactly which blocks are meant to go in which compartment of the sorting tray. And it allows you to help keep those pieces a little bit more organized. I do have some other classroom management suggestions as well that we will touch on. So that's what is actually included in the kit, but then there's also a lot of support and resources that you have access to as well. And we're going to take a look at some of those. So there's actually some unit plans that focus on science and engineering. There's unit plans that focus on computational thinking. There's also for kind of more of an engineering, the maker side of things. There's a teacher guide, there's assessment tools, and then there's also technical support as well. And then there's additions such as extra accessories. We offer replacement packages. As I mentioned, you can purchase a rechargeable battery and charger. Spectrum also offers training and professional development. So I've actually become a certified LEGO Education Master Trainer. There's only about 2, maybe 3 of us now. I actually learned that there is another one here in Canada. One of them is French speaking, so she actually will do bilingual trainings as well. So with the purchase of WeDo, training is always an option. We ultimately want to make sure that you're getting the most out of your set. However, a lot of what I'm going to show you today is hopefully going to highlight how easy it is to be able to get started. So the product works with a variety of different operating systems and coding platforms. So it's supported with iOS, Chrome, Windows, Mac, or Android. The app that is used on a Windows desktop or laptop is identical to the app that is used on, let's say, an iPad or any type of tablet, which is nice. Often when we see apps on tablets, it's usually a much more simplified version, or things are in different locations and it makes it difficult. However, with the continuity between the different supported platforms, it means that even if you have a mixture of technology available in your classroom, it should be easy for you to still teach and run the classroom with, those different devices. There's also different coding languages. So there's the LEGO programming app that's available. It is also compatible with Scratch, OpenRoberta, and Tinker if you download the proper extensions. And if you go on LEGO Education's website, you can view any of the supported platforms or any tips about compatibility for the different coding languages as well. So it's really, really easy to get started. There has been, with WeDo 2.0, there's a new kind of getting started out of the box experience that they've provided. So when you open up your kit for the very first time, it tells you the website that you need to go to download the software, which is where all your teacher resources are going to be and all of your help videos and those types of resources. They also give you some really quick getting started activities right out of the course set. Those are the activities that are kind of like 15 minutes. They're very quick builds with very simple programming that are going to help both you as an educator as well as your students feel really comfortable while they're learning about how the platform works. And then within the app itself, you can access the teacher's guides, which are available in a PDF format. I would encourage you to print them. I have a couple printed copies that I bound them myself, and I find that they're just a really, really quick access if I have them printed and available. But if you're a digital person, you can always save the PDF to iBooks, or you can actually save them on the like on your desktops. You can, for easy access. There's lesson plans and support there as well. So I'm actually going to take you into the app and I'm going to show you how easy it is to find these things. And then we'll come back and we'll talk a little bit more about some of the lessons. So just bear with me. I'm going to switch over to the WeDo 2.0 app, give you a new share. There we go. So I've just so Christine knows, because I know she was having trouble seeing my screen previously. So I've switched from the slides over to the actual WeDo 2.0 software. When you open the software for the first time, it gives you kind of this welcome to LEGO Education 2.0 introduction, and you just toggle through. So you're going to build a LEGO model and connect it to a device. It has built-in Bluetooth, so you can connect it that way. You're going to build your own code by putting programming blocks together. And you're going to press play, the play block, to bring your LEGO model to life. Those are the basics. And then here are there's 4 getting started activities. These are those 15-minute builds. So we do have the ability, we can click right into the builds here if we wanted to. But if I didn't want to, I could close out. And this is kind of the general, the home screen is what I would call it for the WeDo 2.0 app. If I want to start a new project, I just click the plus button down below. I have projects that I've previously worked on. You have the ability to name them or edit them if I want to. I can also delete them. There's classroom projects, teacher resources, or start your first project. So starting your first project is also going to link you to those getting started activities. But I'm actually going to go into classroom projects. So there's about 36 different projects that you can work on. So it does take a minute to load them all. But you'll notice it's organized by getting started. So those are the 4 15-minute activities: the glowing snail, cooling fan, moving satellite, and the spy robot. Then there are 4 activities based around Milo the science rover. So this is essentially, you build him and then you add on to him, you add on to him again, and then you partner with another group who's created him. And those are also a part of the getting started. Then we have some guided science projects, open science projects, computational thinking, both guided and open as well. So I'm going to take you through, I like the cooling fan. It's a personal favorite. So each lesson is set up exactly the same way. So it gives you a time frame for how long the lesson takes. It gives you a level of where you need to be to accomplish that activity. So this one's a beginner. It lists out what you're going to learn. So we're going to learn how to build a quick LEGO model. You're going to connect your model to your device, and you're going to program the motor for 2 different speeds, because this is the fan. And we're going to go, And then it's going to launch into kind of like a storyline that goes along with this. Because it is a primary robot, we like to, have that storyline. And everything to do with WeDo involves Max and Mia and their science lab. So it's a hot day, Max and Mia, their science lab, it's just too warm and they want to build a fan and they need your help. So are you ready to build? And then it provides you with building instructions. And these instructions are great because you can just click through till you get your finished product. Good job when you're done. So it's got that positive affirmation. Then you would go to the next step. It provides you with instructions each and every time you build a model. This is a step that's included. Again, because we're talking about primary grades, we don't want to make any assumptions even after the getting started activities that they know that they need to connect their device. So what it does is it includes it as a part of the instructions every single time. So if we want to connect, it shows you what to do. So the hand is pushing on the button on my Smart Hub. So I'm just going to turn my Smart Hub on. He's going to start blinking and beeping, and then I need to find him in the list and choose him or her. So once I've connected, I get that solid blue color. It's no longer blinking on my screen. It shows up green now. I have the ability to rename it at this time. I also know my battery life and I can disconnect it as well. So I've finished that step. So I'm going to close. And then it's going to pop you right back into the middle of the tutorial where you were as if you never left. The difference is now it's showing that I'm connected rather than asking me to connect. So we're going to make the fan turn on. So it provides you with instructions. And because this is one of the getting started activities, it's actually giving you a hand that's showing you what you need to do. So we need to drag and drop and have it, everything's going to be connected to the play button. And we notice here that this is actually representing the number 2. So this is turning the motor on at level 8, and we actually want to turn it on to a level 2. So that's creating the program is part of it, and then explaining how the fan works is the other part. So at this point in time, if I had the fan built, I have Milo built, so I'm going to show you some other activities with Milo. You would be able to hit the play button and see your fan in action. There's more steps, and the reason I know that there's more steps is there's actually these 6 dots at the top here in the middle, and I'm only on step 4 of this activity. So if I continue on, it's going to give me an additional activity to do. So help Max and Mia further. This is an optional. So you're going to make your fan turn at different speeds and then make it stop. So the students would then have the ability to work with the different icons below in their inventory of programming blocks that they have, and drag and drop and continue to hit that play button and that stop button to be able to see their fan in action. They can also program the fan to do other things. So this is where the projects, they're guided in the beginning and they're a little bit open-ended towards the end so that they can apply their knowledge and kind of take it one step further. Now the last part, this one, in this case, it's a good job and it's encouraging you to move on to do a different lesson, or you can navigate back to the lobby if you wish. In some of the other lessons, you'll see that the last step is a little bit different. It just, it varies. Let me just go back to my PowerPoint. We'll be switching back and forth a little bit between my presentation and the software. I don't want to give you death by PowerPoint, that's for sure. I want to be able to show you some stuff in the software itself. So the lessons that I kind of briefly showed you, the guided projects, the open projects, and the computational, both guided and open as well, They are split into a few different categories. So there's a grouping of them that are applicable to the life sciences. So changes of plants and animals, I know, is in the primary curriculum in most provinces across the country. So that's actually really great for grades 2 or 3, depending on where it falls within your provincial curriculum. There's physical science components as well, where they're building different stable structures and they're testing their designs. And there's also earth and space. So we look at different features, different aspects of earth science, specifically about like tornadoes or earthquakes. There's one all about stable structures and about how they can be affected by different storms or different weather that we're having. There are some that are engineering focused. So those ones are more of the open-ended projects where it provides you with like a challenge or a task, and you kind of have to build or engineer a design on your own. At this age, we do provide them with kind of some suggested builds of where they could build. Let's say the challenge was to create a T-Rex. So they want to make sure that the mouth opens and closes. It will provide building instructions for a model that would open and close. But then the idea is that the students would add on different things, different unique features to make it look or appear like a T-Rex. But the ultimate mechanical part has been provided for them. There's the computational thinking aspect as well. So these ones really focus on more complex programming. So these ones are geared towards more the grade 3 audience, where hopefully they've had previous experience with the product and they're looking to increase their programming abilities and design different programs that are going to be tailored to different situations. There's a whole maker section as well, where they're going to just be designing and making completely unique builds. And then there's also a documentation tool and assessment rubrics as well. And I'm going to be able to show you those within the software. There's these time-saving curriculum tools. I'm going to show you these as well and how to access them. Teachers' notes, curriculum links, assessment rubrics. There's also PDFs of student worksheets that you can print off and have your students use. There's videos that really tie in these lesson plans into real life scenarios. And then of course, there's lots of different building instructions. As I said, there's about 36 different lesson plans. So there's a variety of different builds that the students are going to have access to, depending on what your what curriculum goals you need to meet, or depending on where your students' interest lies. So let's go back into the software. All right, so we're back in the software. So you already saw I went in and we took a look at classroom projects. So that's where all these projects are. And you may have noticed that there were some icons along the top that I didn't show you. So we do have some features here. We can go into any of these lessons. There's the home at the very top left corner. So if you ever want to return to the home or the lobby, you can get there very easily. This book is where we are right now. So these are all the different lessons listed that you can access this way. There's this light bulb, which allows you to access the model library. So there's two ways of looking at the model library. All the models are still the same in both libraries. They're just kind of sorted or categorized differently. So if you wanted to create a model that wobbled, here's the basic building instructions for the wobble, but it applies to both the pull robot lesson as well as a dolphin lesson. And if we scroll down through them all, you'll notice that there's some similarities. So if you wanted to create a reel, you would use the reel in both the helicopter lesson as well as the spider lesson. But where else could we use a reel? Does anyone have any ideas of what kind of challenge or problem or fun activity you could provide for your students where we would use a reel in the building instructions? Yes. Paul says fishing. Does anyone else have any suggestions? Just drop it in your chat, or you can feel, there's a small group of us, so you can feel free to unmute and speak up if you'd like. In a crane, yes. So for like a construction site would be kind of cool. Great, those are some good ideas. That's what I love to see, just how easy it is to take a look at some of these models and create your own custom lesson plans or ideas for extension activities as well. So here's just some of the different ones. There's lift, grab, push, revolve, there's a steering one, sweeping, motion, tilt, turn. So there's 16 different categories and each one has 2 of them. So those are 32 lessons just on their own. Plus there's the 4 getting started, and then there's 4 Milo activities as well, which we're going to look at further. So the other way you can look at the model library is if we switch, we can look at it from a programming aspect. So we look at the library from a building aspect or a programming aspect. So there's lots of different things. So let's say you want to learn today how to send a message and receive a message. There's 2 lessons that offer that feature. So parallel tasks or sending a random message. If you wanted to look at waiting for time, so how do you program to have your robot wait and be patient and take a pause in between 2 different tasks? So wait for time, you can wait for random, or you can do the counter activity. And same thing. So there's 14 if you want to implement how to use a loop. There's 2 different lessons that teach you how to use a loop. Now that doesn't mean that the loop isn't featured in any other lessons. It could. There's lots of crossover between all of the different lessons, but these are just kind of the recommended ones to get you started. So then we go to the camera, and this is where at any time during any of the lessons or any of their own just individual projects, they have the ability to turn a camera on and record their findings. So maybe if your students, if you wanted to do something other than a writing activity, they could record their results or create some type of presentation, or they could record their model in action with maybe a voiceover. They can get really creative about how they're sharing their information. And this is one of the documentation pieces. And this documentation piece will allow educators to be able to evaluate their students' work. So they can also record their program while it's playing as a part of this camera documentation tool. Then if we go to the pen, so we can create other ways of recording our experience or sharing our experience. So we can incorporate images. We can add external video that we maybe filmed on some type of third-party device. So whether it's a cell phone, or maybe it's just on the computer webcam, but it's not through the app. And then they can also do text as well. So they have the ability of, today we learned how to build a fan. And they can play around, they can center it, they can do all sorts of fun stuff there. They can also set up different templates, kind of like a PowerPoint, where they would be able to add text, maybe a video of their model in action, and then maybe a video of, you know, commentary of what's happening as it's happening. It divides the screen up that way. So you can add an image, text, video. So then we have the speech bubble with the question mark. So this is where there's a software guide where it talks in detail about the WeDo toolbar, the different project library that I showed you where all those lesson plans are, the design library. There's a sound recording tool in here as well. So the WeDo will play different sounds, so you can actually record custom sounds, which is fun. The capture tool, that's all about the documentation. So these are just a lot of your guides. Different programming blocks if you want to learn about any of those additional things. If you just click on any of these categories in the left-hand menu, it'll give you some different information or some additional information about it. So this light block lights up the LED on the Smart Hub in a specific color. The color can be changed with numeric input. So each number represents a different color, different sounds. So this is one of the big resources that you can access as an educator to learn more detailed information about every single component of the software. What I want to do though is I actually want to take you through the resource section. So I'm actually going to click my home button and I'm going to return to the lobby or my home screen of the app. So there's this teacher resource section here, and we can access it right here off the lobby, or we can access it from this gear that's in the top right-hand corner. You can click the gear. And it's going to take us into the library of PDFs where your lesson plans are, and it's also going to take you to any of the online resources that are available. You can also change your language. So I'm going to show you what the introduction kind of looks like. So that's that introduction that we played through when I first signed into the app or when I first clicked into the app. You can actually turn that off. Otherwise, every time you enter the app, it will replay that introduction to you. There's information about the lobby. You have the ability of deleting all your projects and starting over. This is just kind of a quick feature. Sometimes like on iPads, specifically on tablets, I find there can kind of be a buildup of different projects from students. And a lot of the time it's just them opening projects, realizing it's not the one for them and moving on to a different project. And all projects automatically save within your lobby. So you do have the ability to delete them. But here's the teacher's guide. So these are PDFs. And if you click into any of them, it's going to provide them in a digital format. As I said, you can save them onto your device, or you can print them and put them in a binder or have them bound just for easy access. Yeah, so you need to have an internet connection to be able to access them within the app. Otherwise, if you wanted to access them offline, that's when you would want to print or have them saved. I'm going to click in this and I'm going to share with you. So it's just a PDF. There is a table of contents. I'm just going to pick some random pages to show you. So it talks about how to use the open projects, talks about how you might recommend documenting your different projects, how you would share those projects after the fact with other groups, you know, talking about the science lab and all about Max and Mia. It's really just a very, very detailed guide, how to prepare your material, teacher preparation versus classroom preparation recommended, what you would want to do before you start a project. If your students need guidance, there's some suggestions there as well. It's about 29 pages. So each one, I'm going to go back to the app. So each one of these teacher guides focus on a different area. So there's the introduction and the toolbox, which are definitely must-haves. And then depending on whether you're working through the science or the computational thinking lessons would depend on which PDF you would want access to. So I'm going to go back to the lobby. There we go. So you can also access teacher resources through the lobby as well. And these are just a few different resources. So the teacher's guides are what we just took a look at. There's also classroom tips and tricks. So again, you do need internet access to be able to take a look at these. So let's take a look at these are the classroom management, the recommended things to do. So it actually advises you to create a set of rules with your class for using the WeDo 2.0 sets. So one of my personal rules when I run a workshop is I have a rule that we don't run robots on the table. When we're ready to run our robots, they either have to be in, if it is on a table, it has to be an enclosed table, meaning that it has walls, which a lot of classrooms don't have. So ultimately my rule is that we run robots on the floor or on a designated area that we've provided for them, just as an example. It recommends that students are grouped into pairs and each pair is provided with a WeDo 2.0 set. One of my other rules is if I'm talking and providing instructions, then the lid to your set should be closed. So whenever I'm doing an introduction to any type of workshop or a webinar where the attendees also have the sets, I usually ask that the lids stay on until I say otherwise. It's awfully hard to provide instructions and have your students engaged and listening to those instructions when all you can hear is of the Lego bricks clattering around in the background. So you want to make sure that you're encouraging your students to ask questions and explore and create throughout, and that there's multiple solutions to a lot of these problems that we're providing them with. So in a lot of cases, there is no one right answer. So we want to be able to give them that freedom to explore and create. You're going to want to allow time for the children to tinker and change their designs. And don't worry too much if you don't finish all the activities in a single session. This one I love. So anytime at the end of the lesson, if there are lost Lego pieces that are found on the floor or maybe are found at a later date, because sometimes minifigures like to take a walk home potentially, or certain pieces take walks. When you find them later on, it allows you to just put them all in one container. And then that way, if you're doing a lesson later on and a student says, Mr., I am missing this specific piece. I'm missing, the green 4-nub Technic building piece. The first place you're going to look for them is in this container where you've designated for kind of your lost and found. That's for Lego pieces only. And that's it in terms of some management activities. We looked at the teacher's guides. We're going to take a look at the teacher's resources side of the lesson plans. So now I got to flip my screen so that you guys can see, because it has actually directed me to a website. You have the ability of following along with me if you wish. If you have enough screens open and you'd like to go to education.lego.com, feel free to do so. You can do so at a later date if you wanted to write that down. It's education.lego.com, and you're going to choose the resources tab, and you're going to go to library, and you're going to choose whatever product interests you the most. So in this case, I'm going to choose the WeDo 2.0 because that's what we're talking about today. And essentially that link took me directly to what I just showed you how to access. So there's multiple ways of kind of getting to the same spot. So here are those teacher's guides. Another way, if you wanted to be able to actually download them, remember I was saying that you did have the ability to save them. You can either access them within the app and save them that way, or you could access them from LEGO Education's website and change them that way as well. Sorry, I was just getting a quick chat. Yes, we will be sharing a recording of this later on. If for whatever reason you don't get the recording, I've included my email address just above in the chat. Feel free to send me an email and I can email you the recording afterwards. These webinars are new to us, I should mention, so we are still working out some kinks. The goal is to have the recordings posted online and emailed to anyone who registered for the webinar. Because sometimes people register and then they can't attend. So that's something we're still working on. So like I said, if you don't get the recording automatically, send me an email and I'll make sure that you get it. Okay, back to the LEGO's website here. So you can have your teacher's guides in different languages as well. If you're bilingual, there is a French guide as well. Then we can take a look at kind of the teacher's side of all of the different lesson plans. I'm going to click into those. Now I have noticed that LEGO's website is a little bit glitchy. Yeah, it took a minute to load there. That's what happened. So here are all the different lessons. So there's about safety, inspection. There's all about the volcano alert, animal senses. Oh, here's the cooling fan. So hopefully you guys recognize this one because I've already showed it to you within the app, more of the student side, you know, what the students would see. If the teachers needed, or if educators needed additional information to help them prepare for the lesson, execute the lesson, and provide assessment for that lesson as well, this is how you would access it. So it provides you with some key objectives, things you need, additional resources. There's also a student worksheet that you can view as well. So this you could provide the students. So rather than giving them verbal instructions, you could actually give them written instructions, either in a printed format or in a digital format. I'm just going to jump back. So it talks about introducing your topic. So remember, it's a hot day. Max and Mia's science lab is too warm and they want to build a fan to cool down the lab. Right, so you're going to notice a lot of mirroring between what's available here and what's available within the app. So, and it also breaks it down for an approximate time frame you should spend on each area of the lesson. These are just recommended though. You're always going to have students in your class that are ahead of everyone else, or students that are behind everyone else. And there's nothing wrong with that. It's the same with adults. When I do workshops, there's always a few keeners that have had lots of building experience or lots of programming experience, and they're done quickly. And I'm going to show you how to manage those. And then there's also people in the group that just tend to maybe chit chat a little bit more. They take their time with building. They're not as familiar. So we want to make sure that we're accommodating that group as well. And I'm going to show you some suggestions for how to deal with those. So it gives you some building. Again, it's going to show you step 3 is connecting. Then all about the programming, and it gives you some recommendations about how to help students with the programming as well. And asking them questions throughout the process. So for example, how does the program work? Have them describe it either verbally or written about how the program works. What do the icons actually mean? And what do the different programming blocks do? Then there's that optional section as well. So these optional sections, excuse me, or extension tasks, these ones are perfect for those students that are done quicker than everyone else. So you can use these extension activities, or you can create your own extension activities and have these students do this so they're continuing to stay engaged and they're not being a distraction to the rest of the class. Then lastly, so this is where things are a little bit different when we're looking at the unit plan teacher resources versus the app. You'll notice when I showed you this exact lesson in the app, it ended after the help Max and Mia further. So here's where we would want to look at providing some type of assessment. So we're going to be giving them feedback, and it'll hopefully help them develop these new skills that they've acquired. So we want to make sure that we're observing the students' behavior, their reactions, and we're listening to what they're saying and doing from a strategies perspective. And this is where you would want to incorporate maybe the documentation tool so that you could either go back later and assess how they were able to kind of process the tasks, as well as you want to be asking questions about their thought process throughout the lesson. So when I'm doing workshops with adults, even, I usually, once I've provided the task and I've kind of said, okay, it's time to get started, open your kits and get building, I take that time to circulate from group to group and ask, how's it going? What are you doing? Do you understand how it works? Show me what you've done, and kind of ask those more open-ended questions, and in hopes of getting a lot of feedback about what's going on. And they can share their excitement level or potentially their struggles with you, so you can help them without providing them with the answers. So here's some assessment criteria that they're recommending just as guidance. So the student is unable to create a program or adequately explain how the model works. Is the student able, without prompting, to create a program or adequately explain how the model works? The student is able to create a program and adequately explain how the model works. The student is able to create a program and explain the programming blocks and how these influence how the model works. So you can either do that like face-to-face, or you could do it through those assessment tools with the video, images, and text. Then it provides you with some next steps as well. So the next steps in this case is to maybe build some type of custom fan that would be completely different, or incorporating some type of sensor that would allow you to turn the fan on and off. For example, the motion sensor. Maybe when the motion sensor sees something, the fan turns on. When it doesn't see anything, it turns off. Or if we were to use the tilt sensor, if it is tilted to this way, we don't use left and right usually too much in primary, but when we tilt the sensor this way, the fan turns on. When we tilt the sensor that way, the fan turns off. So those are just some ideas. And that's how all the lessons look. As we get, this was one of the more getting started ones. So the lesson's a little bit shorter. Remember, it's a 0 to 30 minutes for beginners for grades 1s and 2s. This lesson is a little bit shorter and there's not as many resources available, but we're going to take a look at one of the other lessons as well, and some of the other features within the resources tab. Okay. So that's where we took a look at all the lesson plans, but if I wanted to know specifically which lesson plans were science related or which ones were computational thinking, they've been divided up here as well. So we could take a look at just some of the science ones. And it gives you some recommendations. So these are great for when you're preparing for your lesson. You know, we're going to focus on plants and animals. So I want to find a lesson that is going to fill that curriculum need for me. The plants and pollinators is a great one. So you can take some time to have a look through the lessons, but ultimately you're not being forced to look at every single lesson before you make a decision. I'm going to go back. If I wanted to look at one that's maybe more computational thinking, these are the lessons that are more focused on computational thinking. So all about city safety. So it's going to really focus on the coding and engineering there. Then we also have some other resources. So there's the Scratch how-to video. So if you are, rather than using the LEGO programming environment, the LEGO WeDo app, if you are a Scratch user, there are how-to videos that are going to help you get started with Scratch 3.0, how you would program a WeDo 2.0 medium motor using Scratch. So there's videos, there are help tools there to help you get started. You can download Scratch, getting started, and then, you know, categorizes them there. There's also the quick start guide. So if you've received your set, you're brand new to using WeDo 2.0 and you don't know where to start, here is kind of step-by-step what you do. You unpack your kit, you stick your labels to the wall, you sort everything based on what the card. All of the sets come with these cards that are going to help you organize your kit. They make recommendations that you number every box, the hub, as well as the sensors and the batteries if you have them as well. And that way it's going to, again, that's a classroom management tip, definitely. So you can make sure that kit 1 has a hub, has a tilt sensor, has a motion sensor, has a battery, has the motor, and everything is all together. And then it provides you, step 2, gives you some recommendations about where to get started for teacher preparation, and then some suggestions for classroom preparation as well. It also provides you with a what's in the box. So if you wanted to watch a video, if you were ever going to inventory your kits, and if you are a pen and paper type of person and you want to be able to count the pieces and check off, yes, I've counted 4 tires and they're all there. You do have the ability to download and print an inventory or element survey, it's called. And I really like to have a couple of these on hand so that if I ever need to quickly inventory a kit, I can just pull out a 8.5 by 11 sheet of paper with this on it and make sure that all my pieces are accounted for. And if I'm missing any, then I can make sure that I'm replenishing them. Second to last, we have our downloads. So this is where the system requirements would be. This is where if you needed to download kind of an external copy, or if you're a pen and paper kind of person, you can access the building instructions here and you can even print them off. Programming block descriptions. This is all, a lot of this was in the gear in the app itself. You can actually download what all the blocks actually mean. I've always thought that this would make an excellent poster for the classroom, where for students, and again, at this age, they're going to be very, very visual, but I often find that the visual with the text is really going to help them with learning certain words and their reading and writing as well, so that they can know what each block actually means. So I love that. And then there's your spot where you can download the software or the app. So depending on what you're working with, whether it's Mac, Windows 7, Chrome, Android, iPad, for the Android or like an iPad tablet, you can either go into the Google Play Store or you can go into the App Store. And if you search LEGO Education WeDo 2.0, you're going to be able to find the app, no problem. So you can access them that way. You do not need to own a set to be able to access these resources or any of the software downloads. If you wanted to go and download it today, you are more than welcome to, and then you can take a look at all the different lesson plans and see if it's a fit for you. You can also, obviously, you can play around with the programming. The programming isn't going to be extremely useful without the hardware, but it's a great way of, checking everything out, kind of having, dipping your toe in the water and just seeing if it's for you. So I believe that is it in terms of what I wanted to show you. For kind of like an overview of the hardware as well as an overview of the app. So what I wanted to do next is I have a Milo built right here. So I did want to go through the Milo lesson plan again, just to show you what a lesson plan looks like. Again, I'll do the programming and then I have a document camera set up. So hopefully you can actually see. I'm going to break my own rule too. You'll see it here first. Kristen's breaking your own rule. I'm going to be running a robot on my desk with no barrier. So let's hope my programming is up to snuff because it could go wrong. And I'm going to show you what an actual program looks like in action. So let me just get it sorted out here. We're going to go back to the app. We're going to go into classroom projects. And we are going to take a look at Milo, the science rover. So in this project, first of all, this project is for grades 3 to 5. Personally, I think it's actually more still of a grade 2 or 3 project. It takes about 0 to 35 minutes, depending on how long you spend on it. It is considered one of the getting started activities, so it is at a beginner level. And in this project, we're going to explore different ways that scientists and engineers reach remote places. We're going to create and program Milo the Science Rover, and we're going to document how Milo can help you discover a special plant specimen. We're going to hit go. So Max and Mia are ready to explore the world and make some great discoveries. They will need some help, especially to explore remote places in order to find a special plant specimen. So we're just going to play this video, hopefully. Okay. Okay, so I have a question for all of you. Please drop your response in the chat. Where is, how can I phrase this? If you needed to access somewhere remotely, can you give me some examples of some remote areas that were not provided in the video of where we could send our rover? The north. I'm going to go with, I'll add one in. I'm going to go with for search and rescue. Maybe if it's too dangerous to send people. Does anyone have any other ideas? What are some remote areas? Oops, I sent it just to Christine. We gotta figure this out, everyone. Search and rescue. Earthquake zones, I like it. Maybe in the sewer? I don't know, I don't personally really love to go down there. So there's lots of different areas. All right, let's jump back in here. So what do scientists and engineers do when they cannot get to where they want to explore? That's true, Paul. The Ninja Turtles are already there. I'm just saying personally, I don't want to go down to the sewer. So I'm going to send my rover. So what do scientists and engineers do when they cannot go where they want to explore? So this is where today we're going to build a rover that's going to be able to go places where we maybe cannot or don't want to for different reasons. Maybe it's unsafe, maybe it's unsanitary. There's lots of different reasons. And this is where you'll notice here in this lesson, it kind of is prompting them to use the documentation tool. So at this point in time, I might choose to set up this. And I'm going to say, I'm just going to text it. If I use the camera feature, it will override it doesn't work great because I'm on Zoom. So I'm just going to be using the text feature here for commentary. Okay, so what do scientists do? Scientists create robots that can travel where they can't. And I'm going to write down some areas. So some remote areas might be the following. So we said the north, earthquake zones, search and rescue, and the sewer. Okay, so I've made those notes. Oops. There we go. And I, in order to get back to where I was, I just hit the book icon at the top. I really like this feature too, Paul. I think it's great that throughout, I think sometimes with Lego, kids get really, really excited. Adults get really excited too, and they're like always on to the next step. There's lots of different ways of documenting, but what's nice about this is it's embedded into this lesson. So as an educator, there's student licenses and then there's teacher licenses. So as an educator, you can kind of link them all and you have the ability of going back and seeing what your students have documented throughout. I've also seen educators though just create their own really quick worksheets and have them do like pen and paper as well. Where the app lends itself that you're not going to see is those images and videos so much. So we're going to create Milo, and Milo is a science rover that can move, and there's lots of videos. So I'm going to play the video one more time, and it's going to be really hard to see, but what I want you to pay attention to is during, like when the program is running, different icons within the program are going to light up or activate as the robot is doing that part of the program. So it really gives like a good association between what's happening in the program and what is actually happening with the robot. So again, I'm going to play it one more time. It happens pretty quickly, but in real life, you can see it a little bit better. It does light up with a light blue color as each section is happening. Okay, so we're going to be programming our rover to move forward and then stop. So now's the time when you're going to build your model. You would click start building. You would go through each of the different steps, and then you would have your final little rover made. So I did that ahead of time just to save some time. Again, it would take you through getting connected if you weren't already. It's showing me that I'm already connected. So now it jumps into the programming. So now we're going to program Milo to move forward. And again, this isn't getting started. So it's going to actually prompt me with what I need to do with kind of this transparent hand to get me started. So now I'm just going to be replicating what I see. So I'm going to take the motor and add it this way. I'm going to choose wait. And then I'm going to choose stop. Okay, so my program doesn't quite match, so I need to change this 1 to a 2. And if I ever needed to get rid of any of my icons, there's a few different ways you can do it. If I want to delete it altogether, I just take it and I drag it back to my library, my inventory of blocks. I can get rid of it that way. The other option is to just have it not connected to your program. If it's not connected to the play button, it's not going to recognize this icon. So you could just move it away. Maybe if you just temporarily wanted to see what was going to happen if it wasn't connected, you could just disconnect it and then we can always reconnect it after. If you ever miss an icon, you can always go in and squish one in. Your program will move and make room for it if need be. Okay. Now for the scary part, we're going to run my robot on the desk. So I'm just going to switch my camera view so you guys can see the document camera. I'm going to turn it on. There we go. Okay. I'm going to move it up just so you get a better view. My desk is a little, I cleared off my desk for this. Okay. I'm scared, guys. This never happens. All right, so I'm ready to run my program and I am going to hit play. He went a little bit too far and hit my document camera. So I'm actually going to start him a little bit further back. You can see his shadow right here. And I'm going to run it one more time. This time he actually stopped right before he ran into my camera base. So that's perfect. Couldn't have been more perfect. I've done this before. So for the next step of the tutorial, so now take a picture of you and Milo and write in the documentation tool about what you think about it. And then you're also going to want to share your findings. Explain how Milo can help you in your science project. Good job. And now there's actually 3 other lessons that all have to do about this same build. But I'm actually going to go back a little bit because let's say I'm the brown noser. I build faster than everyone else in my class. I make this program. And now I'm going, teacher, I'm done. I'm done. What do I do next? Now what do I do? What do I do? Does anyone have any ideas of a very simple extension activity that you could provide a student with at this stage without making it too complicated? Because remember, we are just in the getting started activities. Does anyone have any ideas about how to add an extension activity at this point? Now, how do we make the robot back up? Okay. So right now we have the arrows that are facing this way or that way. So what I'm actually going to do, and you'll notice they're down here in my inventory of blocks. So I'm actually going to switch those out. And now I'm going to give it a try. So because he's going backwards and I want to keep him in my camera field for you, I'm actually just going to park him here. Everything's backwards. Everything's the reverse of the document camera, and it's a little hard, a little challenging. Okay, ready, set, go. Hopefully he goes backwards this time. Yep. And he stops. Perfect. All right. Does anyone have any other ideas about how to provide a simple extension activity for this lesson? Have Milo make a noise when he stops. Yeah, that's a good one. When he stops. So these are all my different. That's a dolphin. I like that one. So I'm going to choose number 6. Okay. So setting them back up. Boing. It worked. Thanks, Christine. That's a good one. There's so many different extension activities, especially because we're just in the beginning stages now. Sounds that's a great suggestion, Christine, because I find the kids always love to play with the different sounds and have it make a race car noise or make it sound like a dolphin. And there's so many different options. Another one would be, how can we make it move forward and then move backwards? So we're incorporating both. And again, they can just use trial and error. They have the option of incorporating a different color. So maybe they want the display to change to red when it starts. Have the green light when going, red light when stopped. That's a great one too, right? Kind of simulating that traffic light experience. Really, the idea is that you just want them to play and explore. Maybe I want to make the rover travel twice the distance. So how do I make my robot travel further? How do I make it travel less? There's so many different options for those students. And that's why the lesson plan time for this is just, it's a recommended 0 to 30 minutes, because we could probably spend an hour on this, where the kids, we're just giving them a whole bunch of different activities that they could run through and test before they just jump right into the next lesson. So those are some great examples. Thank you. So I'm going to go back to my documentation tool and do exactly what it said. So what was I able to do during the lesson? So I was able to build the robot? Build the robot or build Milo? Yes. Was I able to follow the program? Yes. Was I able to do some extension activities? Yes. What were some of the extension activities? So we made Milo move forward without falling off the desk. We made Milo move backwards. Again, without falling off the desk. This is huge. We made Milo play a sound when he stopped. And then you could take pictures and different videos and all sorts of different fun stuff to, make it, a little bit more engaging for the students. I go back to the lesson. And as I kind of showed you already, so share your findings. So share with another group is ideally, or share with the class as a whole. And then you could try another lesson where you did about the motion sensor, or maybe about the tilt sensor, or you could do a collaboration activity. The collaboration activity is fun because it allows group A and B to work together, and they can have each Milo moving at maybe a different speed, which allows Milo to be able to turn and do other fun things and just increase collaboration. definitely and working together to achieve a goal or an outcome. All right, I'm going to switch my camera back to me. All right, guys, so that was all that I had prepared for you guys today. We have about 10 more minutes, so I just wanted to open up the floor to any questions that anyone had. Feel free to ask away, or if there's a part of the app or software that I went over too quickly and you'd like to see it more or in depth, I'm happy to provide any additional support as well. So just let me know. Feel free to come off mute, turn your video on, don't turn your video on, whatever you're comfortable with, or drop something in the chat feature. Lastly, I also provided you with my email address. If you don't feel comfortable doing so right now, you can always send me an email and we can connect offline if that's what you would prefer.
Thanks, Kristen. It was great. I had never seen or I'd seen it, but never used the feature with the documentation. So that's I think something that I would recommend to the teachers that we deal with from now on.
It's really fun too, because you don't always have to use like videos of yourself or or pictures of yourself or your robot. You could, like, the great part about all the LEGO products is they can be as easy or as difficult as you make them. So you could actually have the students, if you had more time for your lesson, and let's say you were doing the volcano lesson, you'd be like, you could say, go and write, this is how it can be used in some of the upper grades. If you wanted to go and do the volcano activity, and I want you to go on the internet and find a picture of a volcano, and I want you to tell me about that volcano. And it kind of forces them to do like a little bit of additional research. All right, well, I'll be here till 4:30. So if anyone has any questions, feel free to ask. If not, that's really it for me. Thank you all for joining us for our third LEGO webinar, and I hope to see you all back in 2 weeks when we do STEAM Park. Bye, Paul. Thanks for joining.
Kristen, if you have a few minutes, could you show me an example of what you would consider to be sort of the maximum complex sort of program example you can think of? Like, something with variables or something. Like, I just trying to get a sense of how far I can push this as far as the programming goes.
Sure. I always thought that the sending and the message one was one of the most complex ones. Have you seen that one? Have you played around with that one at all?
I guess, like, how close can I get to what I could do with an EV3 or a Spike Prime? I mean, I know it's less, but I'm just trying to sort of judge. I know I've Keith on here too. Keith's another explorer.
I don't know if you've seen this, and it's not a strictly Lego. It's a guy from Italy who actually does design himself. And it takes 2 sets, but it's pretty cool. It's a sumo bot, and you make the remote controller. Mm. I could send that to you, Christine. It's pretty cool.
Yeah, sure. That'd be great. I can put it in the resource section on our website.
Yeah, that's what I was gonna say. Not the exact same as Keith, but in order to do more with Lego, the Lego WeDo set, you need an additional motor.
Okay.
Or
yeah,
like truthfully, like 2 hubs and 2 extra motors, because the hub only has 2 ports, which is what limits it, right? Because you can't do one motor and both of the sensors, right? You have to either do no movement, so no motors and both sensors, or you have to choose the motor and one of the sensors. But if you had, and then the other thing is that we can't control the wheels independently the way that we can with Spike or EV3. So if you had 2 motors, you could control them both separately. Have you seen how to do
I have seen examples of that, yes.
Yeah, where you can like, you just choose the different, I haven't done it in a really long time. That's a problem.
I haven't run into these questions yet, but I'm just anticipating as our program grows to, you know, for kids, especially if they've done it for a few years,
Yeah.
to what can we do next kind of thing. So I guess that's what I'm really looking to educate myself on more.
Yeah, and then just longer programs too. Like I think that's where the complexity would really come in, is creating like longer, more complicated programs where, you know, it's not just sending a message, but sending a message while having the robot move through like an obstacle course or something, which again, it would only be capable if you had 2 motors to be able to control, to do the turns and stuff. But yeah, I personally haven't done a ton of work with 2 hubs, just because it's like you said, those questions don't get asked to me very frequently. It's not a common way that people are using it. It definitely is capable of more. It's just more the content side isn't there to support it. So you need to go to like those third-party people who are creating their own content, which is super cool. But yeah, I think the one of the more complex things is about like the sending of the message, which ultimately, like once you actually do it, it's actually very straightforward. It's more when to do this and incorporate it with another program as well.
Right. Okay. Gotcha. Okay. Well, that's great. Well, thank you again for your expertise and sharing some tips and tricks. Some of it's stuff that I sort of had forgotten, you know, because I don't use it regularly. So I mean, that part of the program I don't use very regularly. So it's good to be reminded.
No, it's good. And I think a lot of the same thing, a lot of people forget that the resources are there and like how great they actually are. And I think for a lot of beginner people too, who are new to robotics or hesitant with robotics, you know, and actually these resources are there to make it easy.
Yeah, no, it certainly helps a lot. I remember when I started way back when, and the web wasn't what it is now.
I know, and there's so many, and there's YouTube channels and stuff of all these different, I mean, you know, for all the different platforms.
Perfect. Well, thank you so much. Take care.
Yeah, no problem.
Have a great
We'll talk soon.
Bye.
Bye. It's just the Spectrum team left. Colin? Wayne? I guess I shouldn't assume that that's Colin from Spectrum, though. Could be Colin from anywhere. All right, guys, it's 4:30, so I'm gonna end the meeting now. Thanks for joining. Bye.